Radiation or other harsh conditions would be mind-blowing. It would change everything we thought we knew about where life can exist. It might show us that we can find a way to thrive even in places that seem impossible to us. But of course, it's not as easy as it sounds. Discovering life on another planet, especially one as far away and different as Proxima B, is a huge challenge. Scientists will have to use all their skills and the most advanced technology to uncover the secrets of this distant world and its potential for life. How knows we could as well go to Proxima B, travel to Proxima B. The theoretical concept of traveling to Proxima B, exploring distant planets like Proxima B, is really tough because of some big challenges. Right now, our telescopes like the James Webb Space Telescope are exciting at giving us a peek into these faraway worlds, but they can't give us extremely clear pictures or let us do hands-on research because these planets are so far away. To get around these challenges, we need to improve our telescopes and sensors and maybe even create new ways to travel through space. Imagine if we could develop new kinds of engines that could take us to other star systems much faster than we can now. This would open up a whole new world of exploration and discovery. Scientists are already looking into some exciting ideas like solar sails that use sunlight to push spacecraft or ion propulsion that shoots out particles to move forward. There's even talk about warp drives like in science fiction that could bend space to travel faster than the speed of light. But these are still just ideas. We need a lot more research and testing before we can use them to explore other planets. Still, it's exciting to think about the possibilities. Maybe one day we'll have the technology to visit places like Proxima B and see what secrets they hold. The complex path to Proxima and Tor B. Imagine being able to travel to Proxima Centauri, the closest star system to us, and meeting aliens. It might not be as crazy as it sounds. Scientists at the Breakthrough Initiatives are figuring out how to make the journey shorter, from hundreds of years to just a few decades. One big challenge is making sure a spacecraft can keep speeding up as it gets closer to the speed of light, which is extremely fast. Right now, with our current technology, it would still take about 6,000 years to get to Alpha Centauri, the star system that's part of Proxima Centauri. The Starshot project has an exciting idea to use lasers to push a spacecraft toward Alpha Centauri. But here's the tricky part. Earth's atmosphere can mess with the lasers, making it hard to give the spacecraft the right push. Bandhu Tunga, the lead scientist, thinks we can use a special tech called adaptive optics to fix this. Small lasers on satellites would check the atmosphere in real time, helping bigger lasers on the ground stay focused on the spacecraft. These lasers need a ton of power, like all the electricity used in the whole United States, but they only need to be incredibly powerful for a short time. They plan to use 100 million lasers spread out over a big area to send the spacecraft on its way. Once the lasers are turned off, the spacecraft will be zooming through space at an incredible 20% of the speed of light. It would be about 10 m wide and could reach Alpha Centauri in just 22 years. That's faster than a lot of people's lifetimes. When a spacecraft travels to Alpha Centauri, the closest star system to us, it faces some big challenges. First, the pull of the sun and debris in space could slow it down a lot. Even if it reaches Alpha Centauri, it would take another 4 years for its messages to reach Earth. That's like sending a letter and waiting years for a reply. Scientists like Bandhu Tunga and Sibi are working hard to make sure the spacecraft doesn't melt on its journey. They need to make sure the mirror on the spacecraft is nearly perfect, reflecting almost all the light that hits it. They also need to make the spacecraft change direction and slow down quickly to avoid overheating. One of the most interesting parts of this idea is that once they figure out how to launch one spacecraft, they can send more at a reasonable cost. This means they could explore many star systems and increase the chances of finding planets like Earth. Just imagine the possibilities. If we reach Proxima Centauri, we will have a whole new star system to explore. Who knows how many planets like ours might be out there waiting to be discovered. Scientists have already found thousands of exoplanets, which are planets outside our solar system. They made their first official discoveries in 1992, finding planets around a special type of star called a pulsar. 3 years later, they found a planet orbiting a star like our Sun. Since then, they found many more planets, including some that are similar in size to Earth and orbit in the Goldilocks zone of their stars, where it's not too hot or too cold for life. It's an exciting time for space exploration. But you can't be more fascinated by how the JWST discovered this planet. How did the JWST make the discovery? The James Webb Space Telescope is like the superhero of space gadgets. Stationed at a spot called the Second Lagrange Point, or L2, which is about 1.5 million kilometers away from Earth, it helps the JWST stay in a steady orbit as Earth moves around the Sun. Equipped with all sorts of incredible tools, the JWST is designed to uncover the universe's deepest secrets and solve its biggest mysteries. One of its main jobs is to hunt for exoplanets, which are planets outside our solar system, and see if any of them are similar to Earth. And you know what's most exciting? It's going to take a close look at Proxima B, that mysterious planet we've been talking about. The JWST can take pictures and gather information using different types of light, especially infrared light, which is like a secret code that helps us see things that regular light can't. Its main mirror is made up of 18 hexagon-shaped pieces and is a whopping 6.5 m wide. That's taller than two grown-up people standing on top of each other. This big mirror helps the JWST take incredibly clear pictures of exoplanets like Proxima B, much better than any telescope before it. These interesting features of the telescope help it see things that are far away and incredibly faint. Imagine trying to see a firefly twinkling in the dark from far, far away. The size of the telescope's mirrors is extremely important because it helps gather even the tiniest bits of light. This makes the telescope much better at seeing things in space, like the first stars and galaxies that ever existed, or even the faint glimmers bouncing off exoplanets. The James Webb Space Telescope is capturing these tiny bits of light and putting them together to make a clear picture for the first time. But here's the thing about exoplanets. They're not like stars that shine on their own. They're more like mirrors that reflect the light from their stars. They're so small compared to the vastness of space that they look like little dots, just like stars do when you look up at the night sky. We wouldn't even know these exoplanets exist if it weren't for two special things. First, when they pass in front of their stars, they make the stars look a tiny bit dimmer for a little while. It's like a mini eclipse in space. Second, they tug on their stars just a tiny bit with their gravity, which makes the stars wobble just a bit in their orbits. It's like a cosmic dance between the planet and its star, and we can catch them in the act thanks to telescopes like Kepler. Another space telescope has been working hard to spot these wobbles and mini-eclipses. It's found hundreds of exoplanets during its time in space. Until now, we haven't been able to take a close look at the area around Proxima B, that mysterious planet we've been talking about. But guess what? Now, with the JWST, we're about to change all that. The JWST is like a superhero telescope with 4 awesome tools: a near-infrared camera, NIRCam, a near-infrared spectrograph, NIRSpec, a near-infrared instrument, nearest, and a mid-infrared instrument, MIRI. These gadgets are going to help us see things in space like never before. These tools can see light from all over the place, even from far away or dark places in space. And you know what's interesting? They can even see different colors of light, from the ones we can see with our eyes to ones we can't see, like infrared light. This special light can help us find out what's in the air around exoplanets like Proxima B. We might even find clues that tell us if there's water or oxygen there. The NIRCam is like the main camera of the JWST, and it's perfect for watching what happens when a planet like Proxima B passes in front of its star. It's like taking a picture when a bird flies in front of the sun. This camera can help us learn about the atmosphere of Proxima B and how it might be different from Earth's. The NIRSpec is an incredible tool because it can split light into different colors like a rainbow. By looking at these colors, scientists can figure out what a thing is made of, how hot it is, and other important things. This will be useful for studying the air around Proxima B and searching for signs of life. MIRI, on the other hand, can see light that's a bit warmer than what the other tools can see. It's like having a special heat vision power. And you won't believe this, MIRI might even be able to spot signals of artificial light coming from Proxima B. That's like finding a secret message in the stars. While MIRI might not be able to spot a single light bulb shining in an alien's home or the bright lights of big cities or industrial areas, it's still an incredible tool. When you combine MIRI with the other tools on the JWST and its huge mirror that gathers lots of light, you get an incredible telescope. When we combine all the incredible tools on the JWST with its big mirror that can gather lots of light, it becomes an incredible telescope. It can see tiny details on exoplanets like Proxima B and maybe even find signs of artificial lights or other clues that intelligent life might be out there. This is a huge leap forward in our quest to find out if we're alone in the universe. Another milestone for human history and discovery. Proxima B is like a stepping stone that helps us understand more about planets far, far away. It's a small step that opens up big possibilities for exploring the universe. But Proxima B is just one piece of the puzzle. There are many types of exoplanets out there, each with its unique features and potential for life. Some exoplanets are like giant balls of gas, similar to our hot Jupiter. Others are rocky, similar to Earth or Mars. There are even super-Earths, which are larger than our planet but smaller than Neptune. Each of these planets offers a different glimpse into the diversity of worlds beyond our solar system. Telescopes like Kepler and the JWST have been crucial in this exploration. Kepler has identified thousands of potential exoplanets, giving us a glimpse of the variety of planets out there. The JWST, with its advanced technology, has taken us even further by helping us understand the atmospheres and compositions of exoplanets like Proxima B. Thanks to these telescopes, we now know more about how planets form, the conditions that might support life, and the diversity of planetary systems across the cosmos. This knowledge is not just interesting. It's also important for guiding future space exploration and expanding our understanding of the universe. Beyond exoplanets, the JWST has made other exciting discoveries. It has helped us see distant galaxies in their early stages, giving us insight into how galaxies form and evolve. It has also shown us more about how stars are born and how galaxies come together, deepening our understanding of the vast universe around us. The James Webb Space Telescope has an incredible ability to see far, far away into the universe, showing us things we could only dream of seeing before. It can look through cosmic dust clouds and capture the faint light from stars that are billions of years old. With this exciting telescope, scientists can learn about how planets form, what the atmospheres of other planets are like, and even how black holes behave in galaxies that are very, very far away. By using the JWST, scientists have not only found answers to questions they already had, but they've also discovered new things to wonder about. This telescope is like a window into the universe, giving us a deeper understanding of space and everything in it. In the future, the JWST will help us learn even more about the early days of the universe. It will show us how galaxies formed and give us more clues about how life might have started. It will also help us study planets outside our solar system called exoplanets and explore galaxies that are so far away we can barely see them. One of the most exciting possibilities is that we might soon discover life on another planet like Proxima B. If we do, it will change everything we know about our place in the universe. Finding life on another planet would show us that life is not just something special to Earth, but something that could be found all over the universe. This discovery would lead to new and exciting advancements in science, helping us understand more about life, where it comes from, and how diverse it can be in the universe. Discovering life on another planet like Proxima B would be an incredible moment in human history. It would make us think deeply about our place in the universe. We might start to think about what it means to be human and how we relate to other forms of life. This discovery could lead to conversations about what responsibilities we have to other beings in the universe. Finding life on Proxima B could also change the way we think about art, literature, and media. We might see new stories and ideas about space exploration and what it means to be part of a larger universe. This could inspire young people to pursue careers in science, technology, engineering, and mathematics, STEM. However, finding life on Proxima B would also bring up some big questions. We would need to think carefully about how we interact with this new life and what impact we might have on them. This would require us to consider the consequences of our actions and how they might affect both our civilization and theirs. The discoveries made through the James Webb Space Telescope have opened up new horizons in our understanding of the universe. We've learned about the birth of stars, explored distant galaxies, and uncovered the mysteries of planets beyond our solar system. This telescope has been like a window into the vastness of space, showing us things we never knew before. The impact of the James Webb Space Telescope on our exploration of the cosmos is huge. It has helped us understand more about planets like Proxima B and has allowed us to study ancient galaxies. Its discoveries have advanced our knowledge of the universe in ways we never imagined.